In this video I want to show you a small example of calling C code from chicken scheme. Yeah, so and the reason I want to show you this is because I needed it in a project I was working on, and yeah, so I looked it up and experimented a bit, and in this video I want to show you just the smallest possible example. So and you can see it right here. So here we have our chicken code. So, and we're using the bind egg for this, so we have to install that first to be able to import it. Then we're binding this function declaration, and then we're calling it and printing the result. And over here we have the C code we are actually calling. So we use we include stdio, and then we define our function, which just takes an argument and prints it with some string before it, whatever, and then returns 1. So pretty straightforward. Yeah, so how can we actually run this? One thing with the chicken egg is you have to compile it. So you can't use it in interactive mode, so with CSI, but you have to compile it with CSC. And I don't think you can actually compile it like this. What you first have to do is you have to create an object file. So you can do this, for example, with GCC and with the C flag, and then we specify our C file. So like this, and here we have an object file. So we turn the C file into an object file. Alright, so next we want to compile our our chicken binary and include our C code within it. So you can do this with CSC, then the chicken code, and the object file, like this. Now we have our chicken example, our example binary, and if we call this, we can see it does exactly what we expect it to. So first, this is the output of the C code, so this right here. And we of course give it the argument 133. So this gets put here. Yeah, so everything like one expects it to work. And we print result, which is of course 1. Okay, so far so good. This is pretty simple. But what's pretty annoying is this right here. So we have to declare our function in line in our chicken code, which most of the time, if you're working with C code that you didn't write yourself, you probably don't want to do that. And even if you did, you still don't want to do that. So what you can do is you can include a header file, which I have prepared. So we can bind include, and this is just I was experimenting with the path. So this is just like to show that you can specify any path, but it doesn't really matter. And we include this test.h file, which is, if we take a look at it, test.h, it is just this one line, so this one function declaration. But you could add like more functions here if you wanted to. So yeah, and if we do the same thing again, so let's remove our example and our test.o and GCC and CSC. So we see it works exactly the same. Yeah, it's pretty much the same. Alright, so, but still this is kind of pretty annoying because we have to compile our chicken scheme code, which is like, if you're developing something, you don't want to do that because you lose the entire REPL workflow thing, of course. So what we can do is we can create a SO, so a shared library file, which we then import. So how we can do this is again with CSC, then example.scm and test.o. So this creates the binary, and now we can specify the shared flag. So then we get a .so. And this now, if we pull up a REPL, we can now load this example.so. Let me make it bigger, like this, and of course it prints this out because we have this call in here, so it actually calls it. Okay, but still, so what we can now do is we can now call this foo function with some argument, doesn't matter, and it calls the C code. And this is, of course, interactive, as you can see. So now you can call your compiled C code within or from the REPL, which is, I think, pretty cool. Yeah, I think that's pretty much about it. So, I mean, this is a toy example, of course, but I think you can see how this can be pretty powerful with more complex stuff. And I might show you the example I was working on, or the thing I needed this for, which is a bit more complex, but also a bit more interesting, and it shows why this interactive thing, like having a C code, be able to interactively call your C code, is pretty nice. But yeah, I think that's pretty much it. So yeah, I hope this was useful somehow, and yeah, have a nice day.